Chapter 11, Section 2, Simplifying Expressions. First we'll define like terms. We remember that we already learned that the terms are constants or variables combined together with multiplication or division. Some examples of a term is 2x y squared. 2 is called a coefficient. It's a constant, and it's multiplied by x, which is a variable, and by y, which is another variable, and the y is squared. So that's a term. Another term would be something like 3x, or it could be 5xy. Now these are all different examples of terms, or we could even have something with a different letter, 2/3 AB. We say we have like terms when the variable part of the term is exactly the same. So 2xy squared and 6xy squared are like terms. Another example would be something like 3x, and we now for the variable to be the like terms, then we have just x here, and we could have -6. Those two are like terms. The variable part is exactly the same. So unlike terms are any terms where the variable part is not exactly the same. So all of these are unlike terms. So as long as it's not like, then it's unlike terms. Next, we're going to talk about combining like terms. We combine like terms by first thing we always do is change all subtraction into addition. So we go through our problem and we change subtraction into addition, because then we can use our properties, commutative, associative, and so on. Then we are going to add the coefficients of all the like terms. So once we add the coefficients, then that's what we mean by combining like terms. So if we have 2xy squared, and it's in an expression where to that we're adding, we could even add this as a -6xy squared. So then we combine our coefficients. Our variable part stays the same, xy squared, and we combine our coefficients. So 2 plus a -6, this would be -4xy squared. Or another example could be 3a plus 5a. Our variable part is exactly the same. So this is like 3 apples, and to that I'm adding 5 apples. Well, of course I can add apples and apples. If I have 3 apples and 5 apples, well, I have 8 apples. 8 times whatever that variable a is. Terms that are not like terms cannot be combined. We just have to leave them as they are. Simplifying expressions. To simplify expressions, we use the distributive property to clear the parentheses, and then we combine all like terms. And that is how we simplify an expression. Let's look at some examples. So in this case, I have 4x plus 22x. My variable part x is exactly the same, x and x. So 4 plus 22, this is 26x. And I can simplify my expression by combining my coefficients. All right, let's look at the next one here. I have 5 multiplied by the quantity 6a plus 3, and then from that we're going to subtract 8a. So first thing we want to do is clear the parenthesis using the distributive principle. So first, 5 times 6a gives me 30a. 5 multiplied by 6, that's 30, and the a just comes along with that. 30a. 5 times 6a is 30a. 5 multiplied by 3, I multiply this through. I have 5 multiplied by 3 is 15. And then I want to change this subtraction into an addition problem. So this will be plus, and I can put a parenthesis around it so that I don't lose that negative. So plus a negative 8a. Well, now that this is addition, I can move things around and I can see that I have an a here and an a here, exactly the same variable part. So those are like terms. 30a plus a negative 8a gives me 22a. And then I just add to that my 15. Because 22a and 15 are not like terms, they do not have the same variable part, we're done. We can't do anything else with that. And so that is my expression simplified as much as it can be simplified. All right, let's look at this one. Negative 5p squared plus 6p minus p squared plus 7 minus 8. All right, well, the first thing we want to do is change all of our subtraction into addition, and then we can move things around. So, and I think this, I'm sorry, it should be minus 8p. All right, so first I want to change it all to addition of the opposite. So I'm going to write, this one stays, negative 5p squared plus 6p plus a negative p squared plus 7 plus negative 8p. Now we can rearrange to put the like terms next to each other to help us out here. So this is negative 5p squared, and then to that I'm going to add a negative p squared, because p squared and p squared are the same, and we'll combine those two, and then plus 6p plus a negative 8p, and then the 7, it doesn't have anything, any other constants with which to just add together there. So now I have negative 5 plus a negative 1. That gives me negative 6p squared. And here I have 6 plus a negative 8. So that will be 6 plus a negative 8 is plus negative 2p. And then I'm going to add the 7. This is a fine way to leave this. We could also change this back to subtraction. Negative 6p squared minus 2p plus 7. And this is simplified. So these two are the same, and it depends on how you prefer to leave it. But this is simplified. Okay, we can leave this either way, as in the parentheses as plus the negative, or we can change it to subtraction. Both of these are simplified expressions. All right, let's try one more here. In this one, we have negative 3q squared minus 10q plus q squared minus 15 plus q. And so we change our subtraction into addition. Minus 3q squared plus a negative 10q plus q squared minus 15 plus a negative 15 plus 5q. All right, now we can move things around. This time I'm just going to do it from where they are. But here I have a q squared, and there I have a q squared. So those two are like terms. This one I have negative 3q squared plus 1q squared. It's like adding negative 3 and 1. We get negative 2q squared. And then here, this one, q, and this one, q, are the same. So I have negative 5 plus, negative 10 plus 5, and that's going to give me negative 5q. And then I just have my minus 15, or we could write that as plus a negative 15. And there we go. That one is also simplified. Let's try one more. This one is 6 multiplied by the quantity y minus 9 minus 5 times the quantity 2y minus 5. All right, so now first thing we're going to do is use the distributive principle to clear the parentheses. So I'm going to multiply 6 by y. I get 6y. And then I'm going to multiply 6 by a negative 9 and get minus 54. And then I'm going to look at this one. I have minus 5 times 2y minus 10y. And then minus 5 times a negative 5. And I have to be careful. This is a negative times a negative, and I have to make sure that that negative goes through with this. I should probably, to be clear, have changed this to plus a negative here. But so this is a negative 5 multiplied by a negative 5. And that gives me two negatives, make a positive, plus 25. Now I can combine like terms. I first will change these to addition of the opposite so that I can rearrange. And then I have 6y and negative 10y. That's going to give me negative 4y. And then I have negative 54 plus 25. And that is going to give me the difference between these two is 29. 29. And since negative 54 is bigger than 25, that will be a minus. Negative 29. So negative 4y plus a negative 29, or negative 4y minus 29, and that is what our expression simplifies to be. All right, let's do one final problem. So this one, we saw in the last one, we had the negative had to be distributed also. So we're going to change this to plus a negative. And then here, though, we have to be careful because there is no coefficient or constant out here. So we just see this negative, but that's because there's an implied 1. And so I encourage you to add the 1 if that helps you. This would be plus a negative 1 multiplied by the quantity 3m minus n. And I can also put the plus a negative n. All right, so let's now distribute to get rid of the parentheses and then combine like terms. So 6 just stays 6. And then I have this negative 1 that I have to distribute. So negative 1 multiplied by 3m is going to give me negative 3m. And then negative 1 multiplied by a negative n is going to give me a positive, or plus a positive n. Now here I have negative 2 multiplied by m. That's going to give me plus a negative 2m. And then negative 2 multiplied by 8 is going to give me plus a negative 16. And then finally plus 5n. All right, let's see if we have any like terms. Here I have an m, and here's an m. So I have those two like terms. Negative 3 plus negative 2. That's going to give me negative 5m. And here I have n and n. So 1n plus 5n is plus 6n. And then I have 6 and negative 16, or plus a negative 10. There we have our reduced or simplified expression.